In this video, we're going to learn how to import an Excel spreadsheet into Stata, look at some basic summary statistics for our variable, and generate z-scores for our data set. So you'll notice we have an Excel sheet open here, very simple. We have a variable called score, and we have a few values. Let's say it's a math test, for example. And to import this into Stata, we can close Excel, go into Stata, click on File, Import, Excel Spreadsheet, click over here to Browse, which will allow us to choose our file to import our data file, and this option is really important right here where it says import first row as variable names. This ensures that the word score, which was in the first row of the Excel sheet, isn't counted as part of the variable, but is actually used as the name of the variable. So we can take a quick preview here. We have a variable called score, and we have some values for that variable. So we hit OK, and now over here in our variables list, we have score imported from Excel into Stata. And if we want to look at what that looks like in Stata, we can just click on the data browser, which will show us our score and then the actual scores for each observation in Stata. So let's say we want to get some summary statistics for this sample. A really easy way to do that in Stata, we can just type out summarize, or sum as an abbreviation, score. And what this gives back to us is the number of observations. So 12 observations, mean of a little over 102, standard deviation of about 17, and a range going from a minimum of 78 to 132. So let's say we wanted to, for this test, we actually knew, because it was a standardized test, that the mean of this test was set at 100 and the standard deviation was set at 15. There are a lot of tests like this. IQ is one example where 100 is the mean and 15 points is a standard deviation. We can use Stata to generate z-scores based on that population information really easily. Instead of calculating it by hand or creating a formula in Excel, we can use the generate command, which is giving us a new variable, and we'll call this one z-score. That makes sense, right? It's a z-score equals, and now we put in the formula for the z-score. So it's going to be the original score minus the mean, which is 100, that we know, divided by the standard deviation, which is 15. Type that out, hit enter, and now we have a second variable in our variables window. And when we open it up in the data browser, we now have z-scores for all of these data sets. So we can see, for example, that a score of 102 is about a tenth of a standard deviation above the mean. And a score of 115 is, as expected, one standard deviation above the mean. So we can use this to really quickly see what the highest and lowest scores are in terms of standard deviation units, which is really, really important for comparing scores that are on different scales.